parallel execution. That is very important to be known. The processor that support the parallel features, okay, can be effectively utilized, of course. And the next one is pre-processing. The execution of the underlying encryption algorithm does not depend on input of the plaintext or ciphertext. Therefore, if sufficient memory is available and security is maintained, pre-processing can be used to prepare the output of the encryption boxes that fit into the exclusive OR functions. Okay, when the plaintext or ciphertext input is presented, that the only computation is a series of exclusive ORs. So that every time we have to. Such a strategy greatly enhances the throughput. That is very important in. So that all because of the parallel features. The next one is the random access. So the ith block of plaintext or ciphertext can be processed in random access fashion. With the chaining mode, the block Ci cannot, you remember, if this block cannot be computed until the previous one computed. So I only can compute the Ci if Ci minus 1 is already computed. There may be application in which a ciphertext is stored and it is desired to decrypt just one block. So for such application, the random access feature is attractive. You can, if you are able to, do it randomly, then it can increase the efficiency of your algorithm. The next one is provable security. It can be shown that CTR is at least secure as the other modes discussed in this section. Okay, at least. The next one, the last one is simplicity. Unlike the ECB and also the CBC, we discussed about the ECB and CBC. The CTR requires only the implementation of the encryption algorithm and not the decryption, only encryption. This matters most when the decryption algorithm differs from the encryption. It does for AES. AES are different. So in addition, the decryption keys scheduling need not to be implemented. So that's why we can say the CTR has more simplicity compared to the ECB and CBC. Right? So we reach to the summary. We discussed about the symmetric encryption principle, about the cryptography, cryptanalysis, facial cipher structure. Then we look at the symmetric block encryption algorithm, like DEA or data encryption standard, DES. We look at the triple DES. We compare with the advanced encryption standard. And also we have seen why basically we need to have the advanced encryption. What are the disadvantages of the or shortcoming of the triple DES? And then why we need the AES. We discuss about the random and pseudo-random numbers. We discuss about the TRNGs, PRNGs, and PRFs, and followed by the stream cipher and RC4. And finally, we discuss about the cipher block modes of operation like ECB, CBC, CFP, and finally CTR. And we have seen the advantages of the CTR compared to the ECB and CBC. Right? That is the end of chapter 2. Okay. In the next chapter, we will go through the public key cryptography and message authentication. Okay. So if you have any question, you can ask me. All right, we have completed lecture 2. Lecture 3, we will look at the public key cryptography and message authentication. So any question, guys, you can ask me during our online class. That should be fine. Okay. So if we look at it quickly, what we will discuss in the next lecture. Public key cryptography and message authentication, and we will look at some of the information about the public key one-way hash function, how we can secure it, and the other information about the hash function. Okay, I think we will discuss about these things in the next video. All right, thank you very much and hope you have enjoyed this lecture, and bye.